Hello everyone. So in this video we are going to solve this question, and this question is taken from HMMT, that is the MIT Math Tournament. It's a guts round, and this is the question from year 2021. And the question says that fx is equal to x cubed minus 3x, a polynomial given, and compute the number of positive divisors of this composition of this function over itself 8 times. So let's try to find out the pattern, and if you want to give a try you can. And of course we don't have to do this calculation as many times it is demanding. And by the way, there's also one thing important, that this is the greatest integer function symbol there. So whatever it comes, we have to find the greatest integer of it, and the result what we are getting, we have to find the number of positive divisors of it. So of course we don't have to do the 8 times iteration, we have to identify the pattern. So if you solve it correctly, if you give an attempt, the answer should come as 6562. So what we are going to do is, here first of all try to understand this x cubed minus 3x is not the just random function is given there. There is some uniqueness inside this function is hidden, and that we have to only crack. So I have fx is equal to x cubed minus 3x, and you notice that this 5/2 is also a very special kind of number. This is the sum of two reciprocals, that is a 2 and 1/2. It means 2 and half. So you see that if I say that this is going to be u, I have this is 1/u. So if I try to crack this pattern at u plus 1/u, maybe we can get the pattern. So I'm going to calculate f of u plus 1/u first, and that will give us u plus 1/u the whole cubed minus 3 times u plus 1/u, and if we expand it, we'll get u cube plus 1/u cube plus 3 times u into 1/u, u plus 1/u, and this guy was already there as it is. So from there you can see that these two get cancelled, and we are getting this thing entirely cancelled. So what I got the pattern, not the pattern so far, but still I realized that f of u plus 1/u is u cubed by 1/u cubed. It means if I want to find the innermost value of the function f at 5/2, it means I can say that is 2 plus 1/2. This is nothing but the innermost 5/2, and that is going to be the 2 cubed plus 1/2 cubed. But again you see the second time you are finding the composition of this, the f of f 2 times, it means f of 5/2. It means you can write there f of 2 cubed 1/2 cubed. But now you notice that this is again a new kind of u. It's again v by 1 by v plus 1/v, or you can again say that this is u. It means what I'm getting is this by the similar process, that f of u plus 1/u is u cubed by 1/u cubed. It means now this is u and is 1/u. So this is going to be the 2 to the power 3 square, not to the power 3 square, to the power 3 to the power 3, because u is now this thing, so power 3, and then plus 1 by 2 to the power 3 the power 3. It means this we can write it as, and that is square, and that is going to be 1 by 2 to the power 3 square. If you don't understand this thing, let me explain one more time, because this is 2 to the power 3, you're writing 3 times, so this is going to be 2 to the power 3 to the power 3 to the power 3, and so that will give us to the power 3 to the power 3 to the power 3 is to the power 3, and that is going to be 3. So it will give 3, we're adding 3 times, so 3 square, and so on. So let's take one more time to understand this thing better, and let's try to crack the pattern. You notice so far what we are getting is, this is, I am applying the process 2 times. This if I'm taking 2 times, so this is 2 there, 2 times I'm taking the process, this 2 is coming over the power of 3. So is it followed for the same if I take the 3 times? So f of f 5 by 2. So this is 3 times I'm taking here. So it means whatever I'm getting there, again I'm applying f on it. So that is going to be f of 3 squared and plus 1 by 2 3 squared. And so this is going to be again by using this to the power 3 square to the power 3, and then plus 1 by to the power 3 square to the power 3. It means again you're writing this thing 3 times. So what will get it here? This will be 3 square 3 times. So 3 square 3 times means you're adding 3 square 3 square 3 square. That means 3 to the power 3 will come. Now you can see, so you can write 3 to the power 2 to the power 3 to the power 3, and there is also 3 to the power 3. It means if I iterate this process n times, so I will get rid f of, let's say, n. I'm writing 5 by 2. I must get 2 3 to the power n and plus 1 by 2 3 to the power n. And in this question they're asking that the iteration is happening 8 times. It means I will apply this 8 times, so it will give you f of 8. 5 by 2 is 2 to the power 3 to the power 8 plus 1 by 2 3 to the power 8. But notice we have to evaluate the integral part of this function, means whatever result is coming. So what is the integral part of this? So the greatest integer function of, I'm using the same symbol in the question what we have. So that is going to be the integer part of 2 to the power 3 to the power 8 plus 1 by 2 to the power 3 to the power 8. So the greatest integer of this, because it doesn't matter what the value we are getting here, this quantity is going to be a very small number lying between 0 and 1. So the greatest integer is coming out to be only the first part, that is twice of, not twice of, 2 to the power 3 to the power 8. Now you have to find out the number of divisors of this quantity. So number of divisors, so all the divisors we have to find of 2 to the power 3 to the power 8. So you have done in permutation combination that if I have to find the number of divisors of any prime power, so suppose I have the prime number p and to the power, let's say, n, so the number of total divisors is n plus 1. So here what I'm getting is the number of divisors is equal to 3 to the power 8 plus 1. And 3 to the power 8, if you calculate it, it is going to be 9 to the power 4 perhaps. Yes, 9 to the power 4 plus 1. And so 81 plus 1. So 81 square, let's find it, what we are getting it here, 81, so 1, then 8 and 8, 16 and 64, 65. So this is going to be 65, 61 plus 1, and that is going to be 6562 as our final answer as we have. Okay, so this is a way to find it out. There is another way by complex number and all, but the complex number method is same, exactly same the way we have done in the real part, I mean real version of it. That's all for today's video. See you in the next video with some other problem that what I think you must try. Stay math active.